Expeditions were sent to the Kumtor area as far back as under the Russian Tsars. The first serious exploration here started in the 1920s, but it wasn't until 1978 that the Kumtor deposit itself was discovered. This building dates back precisely to that period. It was part of the Soviet geological settlement constructed by the Kumtor exploration team. During Soviet times, the Kumtor deposit was estimated to contain 316 tons of gold. About 200 tons were thought to be extractable using open-pit mining techniques. Nevertheless, the political leadership of the USSR rejected the feasibility report submitted by the Chief Department of Precious Metals and Diamonds under the USSR Council of Ministers as too costly. According to the miners' estimates, about 1 billion Soviet rubles, or about $1.5 billion US, was needed to build the infrastructure. Development started only after Kyrgyzstan had obtained independence and was based on foreign investment. In fact, Canadian investors spent a mere $452 million to build the mine. Moreover, they did it in record time. Kumtor Operating Company was formed in 1993, while commercial gold production was underway by 1997. The Kumtor reserves have been re-evaluated many times since the discovery of the deposit. For accuracy reasons, this has become an annual practice. Yet, it should be mentioned that the open-pit mining method has yielded more gold than was estimated in the late 1980s by Soviet experts. Before producing gold, you must find the correct place to mine. This is the main task of Kumtor geologists engaged in daily exploration. The Kumtor deposit is located in the so-called Kumtor Trend within the Tian Shan gold belt that was formed over 200 million years ago. This belt stretches from eastern Kyrgyzstan, the upper reaches of the river Sarijaz, to western Uzbekistan, the Muruntau deposit. The deposit's gold reserves are still quite considerable. Kumtor's gold cannot be seen by the naked eye because, in geological terms, it's fine dispersed. This means that microscopic pieces form parts of other minerals.
You will not see gold here because it's too fine, about 5 microns in size.
It's part of a mineral called pyrite, isn't it?
True. It is found mostly in pyrite, but our latest research shows that it can either be free or form parts of other minerals.
So, Kumtor's gold is found mostly in pyrite and rarely in chalcopyrite. By the way, the latter, sometimes called fool's gold, is often taken for gold because of the way it shines. To locate the gold, geologists have to examine the finest ore cuts, up to 30 microns thick, under a microscope. In comparison, a human hair is normally 80 microns thick.
Here's a gold particle fused into pyrite and grey copper ore. It's on the border between the grey copper ore and pyrite. Here's another one, in non-metallic ore, also fused into grey copper ore.
Using drilling rigs, the geologists search for gold all over the deposit area, day and night. They take core samples to see whether the sections they are exploring contain gold and in what amount. The drilling process is underway now. This is the rotary part of the drill core that gradually moves underground at an angle of 68 degrees, making 1,600 revolutions per minute. We have advanced 270 meters so far. We need to drill more than 600 meters. When it reaches this mark, one more well tube will be attached and drilling will go on. Is the drilling going smoothly?
Yeah, it's going all right.
It looks like it's not the most difficult section, am I right?
Yeah, some other places are definitely more difficult.
For example?
It was more difficult in the pit. At Saritor too. The pit is rather complicated.
What drilling method do you use?
We use the hydraulic rotary method. We supply water to the hole and remove rock by rotation and attrition.
According to Roman, this hole is rather easy to drill. That said, it's still quite a feat, especially as all this happens at over 4,000 meters above sea level and at bitter sub-zero temperatures. These cuts, or polished sections, were prepared by Alexander, a sample taker.
This is what the geologists bring here, after cutting cores, for processing and preparing mineralogical samples. After that, they examine them under a microscope.
Sometimes even the polished sections cannot help determine gold content. In such cases, all you can see in the polished ore is pyrite and chalcopyrite inclusions. Is this gold?
No, all that glitters is not gold.
Ah, I see.
These are different minerals that behave like this in the transmitted light.
All these samples are taken from ore that was recovered underground. They are long bars, called cores, that are produced during drilling. Which of the core sections contains gold for sure?
Here is a section represented by so-called metasomatites. They're here in this sample of albite quartz. There's gold in here. At the moment, I can't tell the exact amount. The sample needs to be described, documented and tested first. The results will be clear after analysis.
The final decision as to whether the gold is present in an area under exploration will be made in this laboratory.
We are an assay lab, whose mission is to assay ore supplied by various departments, by geologists, exploration experts who use diamond drilling, and by the mill itself, which needs to monitor ore processing.
The assay lab appeared at Kumtor before many of the other facilities, including the gold mill, were built. This makes sense, as exploration here had begun a few years before the first commercial gold was produced. Jokingly, the lab employees say that, like bomb diffusers, they have no right to error. They decide whether large-scale mining operations will be carried out in an area of the deposit. It is upon the results of their work that multi-million-dollar investments and the work of thousands of people depend. That's why the lab employees very carefully examine all the materials supplied by the geologists. They even do trial melting of gold. First, ore samples are mixed with the appropriate components. Next, special chemicals are added that are necessary for ore assaying, after which the porcelain crucibles are placed in small melting furnaces, and a lab melting starts at a temperature of 1100 degrees Celsius. After some time, the samples are taken out of the furnace. When they cool, the glass that was formed during the melting will be removed, and the sample will be sent for analysis. With the assay results in hand, the lab employees will produce reports on the gold content of the sample in question. It is only after the lab makes their final decision that the other mining departments will decide where and how they are going to mine and process the ore. Exploration has enabled the company to extend the Kumtor open pit mine's life to 2019, with production plans until 2026.